to go through this question. And did you understood it? I saw Kishan posted the solution. I didn't checked it yet. I'll be checking it after the class. So yeah. Other than Kishan, did anyone got the chance? Okay. Vishnu is saying yes. Mani, okay. Mani and Vishnu, did I assume that you two guys got it? And yeah, how many of you want me to do the analysis once again? Not getting the minimum value. Okay, I'll check that. And those who were confused with the analysis part, I'll just do it right now. Okay, so let's quickly go through it. In this particular code, like the initial parameters that we will be passing are permutation of array. This is an, you can say, empty array, which we are gonna fill. Then taken array, you know that we are taking this array as a Boolean values to know whether a particular number is taken or not. Okay. Next is index. So index will be 0 as of now because you have not filled any value. And next is main array, which I'll be like, as of now, I'm taking it as MR. So this will be used to check if the current array is the magic square or not. Like when we'll check this array is magic square or not, then main array is for getting the costing to convert this particular like the main array to a magic square. Clear? Are you
So
all clear with the parameters?
main array means initial array, like
Yeah, correct.
okay, okay.
Okay, so it's not even the initial array, it is the array which you have converted from a 3 by 3 matrix. Okay, I hope you all remember that from yesterday. Now, like I'll start from the beginning from 0. It will check if index is equal 9. So this condition will be false. Hence, it won't enter this particular part and directly go into this for loop. So here I will start from 1. It will check if taken of I is equal false. In case of the taken array, it will be of size 10, where we are like considering each number is whether taken or not. So we are just ignoring the number at the 0th index, and the remaining is giving us the flag or the value whether this particular number is taken or not.
So if we are ignoring the first one, then we will be short of one element
Why
because
so?
we there are in all 9 elements,
So
and if
I'm
we ignore,
taking the taken array of 10 elements
okay,
now.
okay, fine.
Okay. Okay, then so I've taken this taken array. I'll just write it as T. And now it will check if taken of I is equal false. This condition will be true. Hence, it will come in and make taken of I as true. So this will be made as true. Next is array of index equals to I. So your array here will start filling now. And your I is a starting array of index that is 0. And your I value is 1. So this will be filled with 1. Next is again, it is calling the permutation. Now see what is happening. This was the stack call for index equals to 0. Equals to 0. Okay. So in this particular like call, what happened in the first iteration itself, we are calling the permutation function again. So there are 8 remaining iterations which are still like here pending to happen. Clear? 8, like I'm just pointing out 8. That means 8 iterations are pending over here. Now what will happen next? It is calling the permutation function again, where now your index will be 1. It will check if 1 is equal 9. It will be false. Then it will again enter this for loop and it will start I from 1 again. So it will check if taken of I is equal false. Is it true now? No. So what will happen?
Just you're checking at the second position now because it has gone through the one loop.
Yeah, it has gone through the one loop, but the point is it has called this permutation function again, right?
Yeah.
So it will again start all the things again. That means the for loop also start from I equals to 1 only.
Yes.
And when it will check for taken of 1 is equal false, it is like the condition is wrong now, because you can see that taken of 1 is true now,
Right.
right? So it will now iterate in this for loop, make the I value as 2. I'll just write here I value is 2 already written. And now it will check if taken of 2 is equal false. Is it false? Like nothing is mentioned. Take it as like all the values are false as of now. Okay. So this will be true now. And it will come in, make your taken of I as true. Fill your array, like fill your array of 1 position with 2. And now again make a call to the permutations function. Is it clear now? Yes. Now just give me a minute. Okay. So what will happen now? 2 iterations has happened for this particular case. 7 iterations are still pending. Is it clear? Sure.
Ma'am, one question.
Yes.
Inside the for loop, when we are passing permutation, we also need to pass the
Fourth
mark.
parameter. Yeah, that's right. Actually, I updated the 4th parameter at the end. That's why it is not mentioned over here.
That's fine. Okay. So there'll be no change in the mark, MAR.
Yeah, obviously there won't be any change because it is only needed to find the minimum cost. That's it, nothing else.
Okay, got it.
And now it will again call this permutation function. So now when it will go with the index value as 2. Okay. So for index value of 2, 2 is not equals to 9. Again, it will enter this for loop. It will check for I equals to 1 if taken of I is equal false. Is it false?
For the third time, yes, it will be false.
I'm talking about the first case, that is I equals to 1.
No,
It is not false.
it
Then
is
it will
true.
check for I equals to 2. Again, it's not false. Then it will iterate for the third time, that is I equals to 3. And for the third time, it will be false. So this third position will be filled with true. Your array will be filled with like array of index. This is 2, this is 1, and this is 0. Okay, so this will be filled with 3. And now, as soon as it is filled, it is again calling the permutation function. So what will happen now? 6 iterations are remaining here, and it will make a call to another stack. For this, like this was for index equals to 0, this was for 1, this was for 2, and now this is called for 3. When this is called for 3, again it will check if 3 is equal 9. No. Then you all know that now it will run for I equals to 1. It won't be entering this if condition. It will run for I equals to 2. It won't be entering this if condition. For I equals to 3, again, it won't be entering. But when it will run for I equals to 4, it will enter this if condition, make this taken off 4 equals to true, and fill this particular position with 4. Clear? And here, the number of remaining iterations will be 5. Clear to everyone? Yes. So now coming on to, like, I'm not gonna repeat the same thing again. I'm just doing here for the fourth index, the number of remaining iterations will be 4. This fifth index will be true now, and this will be filled with 5. Next, for index equals to 5, the number of remaining iterations will be 3. This will be filled with 6, and this will be made as true. Everyone, are you getting it, or should I like continue traversing the same way, the way I was doing? Because it is like repetitive now, that's why I'm not doing it. Getting okay. For index equals to 6, the number of remaining iterations will be 2. This will be made as true here. And here, this will be made as 7. For index equal to 7, let me just write the indexes. Number of remaining iteration will be 1. And this will be filled with 8. For index equals, and this will be true. For index equals to 8, number of iterations remaining will be 0. And this will be marked as true. And here it will be filled with 9. I hope you all understood the first set. Yes, no? Yes. Now we'll see what will happen further. As soon as this like this 9 is filled, like this particular part will be executed. Let me just show you. This part will be executed.
I have a small doubt that taken, I mean, just to make it simple, why we are keeping the 0th element as empty? I mean, to make the simple, we can all start with 0 to 8 instead of keeping the first one.
Yeah, but the thing is, like, we are making it simple in a way that if 1 is true, then we know that one number is taken. If 2 is true, we know that second number is taken. So we are not here concerned that, okay, if it is at this, if 0th index is true, then okay, 1 is taken. If first index is true, then second is taken. So it will create a little confusion rather than this. Okay, like when you see 1, okay, things that the thing will click in the mind that, okay, 1 is taken. So that's why we are not making the making take an array complicated, and we are just using a 1 extra space, which is not that much. Okay.
Yeah, I got it. Thanks.
Okay. So now you all understand that this part will be executed for the last stack, that is taken of I is made as true for 9, and array of index is like filled with 9 value. Okay. After this, when permutation function is called again, This time your index will now become 9. Here your index has now become 9. So what will happen? This condition will be matched, that is index is equal 9. Now this particular logic will be executed. No matter what answer you are getting from here, we are not bothered about it. We are seeing the process here, okay? Because I told you all that writing the magic square function and writing the cost function is not that of a big task. Clear, everyone?
Yeah, ma'am, one more small doubt. In this for loop, I should be less than 9 or less than equal to 9, because I was thinking that when it is 9, then it still it'll go get into the loop. So what I'm saying is
Yeah,
in
it
the
already got into the loop, right? That's why 9 is filled in this particular array. Getting this? The
so
loop started with 1. It started filling from 1 and it is filling till 9. And we want the numbers till 9 because it is a 3 cross 3 matrix and we
yes.
want the numbers from 1 to 9.
Okay, I got it.
Clear?
Yeah.
So when this particular function will return something, returning in the sense, it will go back to its previous stack. Okay. Now in this previous stack, you can see that this like number of iterations here are 0. That means we need not execute any iterations. But there was one thing left in the stack, which was we didn't made that taken of I equals to false. Taken of I means your I value here is 9. So this value will cut down from here and this will be made as false. Clear? Okay. Is there anything left from here?
No, I'm not clear. Like the last part, that after taken n equal to false. So
See, you understand that when index is equal 9,
yeah,
this if condition will be executed and it will return, right?
yeah.
What do you mean by return? Return means it is going to return to its calling function.
Okay, yeah,
Clear? So
yeah.
this was its calling function or calling recursive stack.
Okay,
Yeah.
right.
When we will return to this stack, returning means you execute all your remaining function, like remaining statements which are left. Okay. So
Yes.
in this particular recursive stack, only one statement was remaining. That is, we have
Okay,
to make taken of I equals to false.
I got it. Yeah.
Clear? In
Yes.
this particular stack, I value was 9. So
Yeah.
taken of 9 will be made as false. Clear
Got it.
now?
Yeah, yeah.
Okay. Now, once this is executed, what will happen? Number of iterations are completed. Are you getting this, everyone? When number of iterations are completed, it will go back here. Okay. It will go back to its previous function now. And now here, what it will see, it has to make taken of I equals to false. But for this taken of I value was 8. And this will be made as false. Clear to everyone till now? Okay. After this, you can see one iteration is remaining. That is, I value was 8 till now. So when this taken of I will be executed, it will iterate one more time with value of like with I value as 9. Clear? Now, when this will iterate with I value as 9, it will check if taken of I is equal false. So is taken of 9 equal false? Why 9? Okay. This in this particular stack, Kishan, what was your value of I? The value of I was 9 in this stack. Okay, we have already returned from here. For this stack, I value is 8. Okay. Now, I told you that this taken of I will be made as false. That is, taken of 8 is made as false. Clear till now? Then you can see one iteration is remaining. That means it will go back again to the for loop, increase the value of I, and now this 8 will be made as 9. That was I was talking about. Clear now? Now when it will come in and check if taken of I is equal false, it will find out that taken of 9 is equals to false, right? So now it will make taken of I equals to true. This particular value will be cut down and taken of 9 will be made as true again. Clear? And array of index will be filled with I. For this particular stack, index value was 7, right? Hence, at the 7th index, I value will be filled, which is nothing but 9 here. Clear? Except Kishan, everyone else. Okay. Because I can see only that person is writing yes, 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 and others are all quite. Okay. Now, this particular function call is executed completely. This will again go, and now it will call the permutation function with, I'll just erase this stack. Yeah, it will again call this a stack with array index plus 1, that was index was 7, 7 plus 1, that is 8. So this stack will be called again. Taken obviously will be the same and main array will be the same. When this will be called, it will check if index is equal 9. Is index equals to 9? No, it is 8 as of now. So it will enter here and it will check if taken of 1 is equals to false, obviously not. Then it will check if taken of 2 is equals to false, obviously not. It will keep continuing with all the values until it find 8. Once it find the 8, it will make taken of I equals to false, like taken of I equals to true. That is, it will make this taken of 8 equals to true. And it will fill array of index with I. Your array of index value, like index value is 8. So at the index 8, it is going to fill the value of I, which is nothing but 8. Okay, so this is how your values are switched. And now when it will again call the permutation function, that means again it will go up with the index value as 9. Okay, and 9, you know that it is going to return again. And same thing will continue for the remaining stacks until these complete iterations are finished. Once these iterations are finished, then only you get out of this particular function call. Clear, everyone? Anyone? Yes.
So one thing is there, like I have one doubt, like we are all putting it in a stack.
We are not putting it in a stack. Whenever you call recursive function or recursion,
Yeah,
your program automatically creates the recursive stack for you. Like internally it works, okay? You need not create it externally.
right. Okay. So I am thinking that it is creating 9 times, so there are 9 different stacks. As it comes back, it will keep on while. Yeah, okay. I think, yeah. So at the end of it, what we'll get is just factorial 9 combinations.
Yes, right.
Okay, I think, yeah, that's fine.
Okay, so anyone still having any they got confused in the process, or is it okay now? Yes, guys, I'm waiting for your responses.
So supposing if we want to print all the 9 factorial combinations, we will put the system.out within the index equal to 9 and then try to get the thing.
Like what do you want to get?
So I want to see what all squares are possible, like 3 cross 3 combinations are possible with 1 to 9.
Yeah, you can try that. It's not an issue.
Okay. Yeah. Okay. Once we write this program, then it will be 100% clear.
Yeah, you all can write it. Yes, guys, I can see only Kishan is yeah. Yeah, it can be said, Kishan. Okay. So remaining people in the class. Only Kishan I have seen. Okay, he's good. Vishnu is saying he's good. What about the remaining? Aman, Ashish, Bhuvnesh, Gaurav, Mohan, Sai, Mani. What about you guys? We'll try program. Okay. Because you guys, if having any issues right now in understanding it, just tell me. I'll try to explain it once again. Just don't keep your doubts with yourself as of now. Okay, cool. If no one is responding now, so cool. Could you check my code is running on not able to get that? Yeah, I'll check that question. Probably it will be some problem with the magic square function or some costing function. I'll check it. We'll write it and get back to you. Sure. That's great. So was it an interesting problem? Yes. Too much. Okay. My experience with this problem was like it was just a magic square problem, and that too the in the you can say in the instructions it was specified that it will be only 3 by 3 matrix. So I thought I can apply any kind of brute force and it will work, but later I realized that it's not that as simple as it look. Backtracking is awesome. Yeah, you are gonna enjoy it when you are gonna learn BP. BP is way too much interesting. Yeah, an interviewer will love you also if you explain it in a very clear way and he is able to get everything which you are saying. uh Sorry, Kishan, I didn't get you. Actually, I'm not getting it. PP. Oh, sorry, not Kishan, Vishnu. Vishnu, you can unmute and ask.
Yeah. So I heard this PP. Is it something new topic or is it related to this only?
No, I didn't say PP. It's DP, dynamic programming.
Okay. Okay.
Okay. So our last question for this particular topic is, you have been given a list of strings.
Ma'am, in order to complete this, we still need to write this MS function, minimum cost function.
Yeah, obviously you need to write it. Otherwise, this particular question isn't complete.
So it's our homework.
Yeah, because I don't like expect from you all now that you won't be able to do that magic square function now, because that magic square function is simply like you have two arrays.
Mhm.
Yeah, you just have one array and you need to find out whether the sum of all its rows, columns, and diagonals are equal or not. So I
Yes.
can't tell you how to traverse in an array those columns and diagonals now because you're learning recursion now.
Okay.
So I guess the class is mature enough now to do that. And if you're stuck anywhere, obviously I'm there. Okay. Oh, did you send me the code, Kishan? Sorry, I didn't look at it as of now. Have you pinged it? Okay, you're not. Okay, I'll ping you the solution for this for sure. Okay, so you have been given list of string and you have been given a string itself. That is, I can say, yep. So this is the string given to you, and this is given you the list of strings. You need to figure out if it is possible to like get this string by integrating these strings. Like any of these strings you integrate and you're going to get this resultant string. If it is possible, return yes or true. If it is not possible, then you need to return false. Clear? Yes. And there can be one more like variant of this question. It can be, if this string is possible, then how many ways it can be formed? Like you can see, if I merge Ashok and IT, it will be Ashok IT one way. If I'll merge this AS and HOK Ashok, and then I separately and T separately, this will be one way. I can merge it as AS, HOK, and then IT together. So there can be multiple ways to form this string. So one way can be this true and false thing, if this string is possible or not. Other way it can be that in how many ways this string can be integrated. Clear? So these are the two variants of this question. Anyone have any questions? Okay, guys. So I recommend you all take some time to understand this. I'm giving you 3 minutes of time for this question to understand. Otherwise, we will start doing this question.
I have some questions. Do you have to find all the permutations or just yes?
The second question, in the second question, you have to find all the ways you can form a Ashok IT. That is the second question, like second variant of this question. In the first one, you just need to find if this string is possible or not.
So using brute force, we can just loop it and then find out whether it's possible or not. First problem.
How can you loop that, right? Like right now, I have written it as Ashok. Okay. What if I'll just give you a variant as like string variant as S H A K and O. How will you do that?
Okay. So all we have to find out whether Ashok is there in the can it be made or not.
No, you need to figure out if Ashok ID can be made out of the given string.
Okay. Okay. Mm. So I'm thinking that how we made sets in the past, like all possible sets,
Okay.
and then concatenate them
How
to
to
compare.
form all the sets? How did we formed all the sets? Do you remember?
And- but we did that at some point.
Okay, okay. Others, did you thought using two for loops? Kishan, you can also tell me like what approach you are thinking. Yes, can you unmute and tell me your approach? Okay, I'm answering to
Ma'am,
Vishnu's question.
one second, ma'am. In the past, in the same we had done for numbers like 3, -4, 8, and 0. We formed
Yeah.
different subsets, but
Mm-hmm.
here
Okay.
this variant has characters, and it could
It
be.
don't has characters, it has strings. Okay. And with strings, you cannot have the sets because internally you need to traverse individual string as well. Are you getting that?
Individual strings.
Like, let's suppose you have this string HOK. Okay. And you have in your subset as A and HOK. So you need to traverse on that HOK individually to see if it is forming your current string or not. Are you able to follow?
Yeah.
The subset part is right. We need to actually divide it, but think a little bit more. Okay, do you
I will
want?
try.
Yeah, okay.
Hello.
Yeah, you can try,
Yeah,
Sai.
ma'am. Yeah, we'll take two for loops.
Okay.
Okay, outside the string is Ashok IT.
Mm-hmm.
Okay, so first for loop it will iterate and first it will fetch the Ashok. Okay, so for second for loop, right, I will combine this one Ashok and IT. Okay, I will check with Ashok IT is equally or not with that string. If it is not, I will append on as. Like this, I will append.
Imagine this is your list of string. Okay, don't take the first one as your answer. Imagine this, like let's suppose, okay, here is your IT. Okay, this is your string. Now, can you tell me if Ashok IT is possible or not?
Yeah, reverse also. Okay. Yeah, that's time it will not work.
Because here, what is happening now? You all are seeing Ashok and you're like, okay, when we'll travel, we'll be getting this word
Yes.
and it will be easy. But how about different permutations? How about these kind of list? In that case, you won't be, right?
Okay. Yeah. Correct. Got it.
Yeah. Any better way to do it? You know,
So
there's a concept. Yeah.
one thing I was thinking that I'll start the iteration with the final string that is Ashok IT. So I'm assuming that the first character in the final array is A. So I'll start looking in this given array A first, then second element in the final array is S. Then I'll look for second element in the given array S. If I find it, then I'll.
Sorry. I am not getting you.
Oh, okay. So given array is str.
It's
Yes,
not
yes.
an array, it's a string.
Yeah. So I'll make it into an array.
Okay, character array. Continue.
Yeah, character array. And the given like sandbox of characters are on the right. So I will see the first position of the array is A. So I'll start looking for A in the given array, then look for S.
You are saying that in the given array, individually, you will look for the characters, right?
Yeah, starting from left to the right.
What if there are no individual characters? There is like AS. Then what will you do in that case?
Uh, so if there are more than one characters, then I'll compare with
Like not more than one characters. I'm saying they are merged strings. Like here, in the first one, you are able to see as individual characters, right?
yeah.
But what if they are merged? What will you do in that case?
So in that case, I'm just thinking that if they're merged, then I'll compare with the merged with the substring of that length.
Correct. That's where you're getting right now. You need to find the substrings, okay? How? Take this A, okay? Like individually find the substring. Try to find, like, make this substring as A and try to find it out in the list. Like, list has a function called list.contains and check if A is there or not. Okay. If A is there, then you have got your first part. What will it do now? Now it will start from S. Again, wait a minute. Let me just remove few of the things. So now. Let's just keep it in this way and close this. When it will check for S, will it be able to find S in this entire list? Guys, I am like
In the list,
we will first find the substring of just one character, that is A. We figured out A is there. That means this is returning true. The next time when we will be searching for another substring, we want to figure out if this string exists or not, right? So we will start from S. Is S there in this entire list? I'm talking about the first list. No. Let me just remove this as just a minute. Okay. So S is not there. What it will do now, it will increase the length of its substring. What does it mean? Now it will search for SH. Is SH there in this entire list? No. Next, it will search for SHO. Is SHO there in this entire list? Yes, it is there. So it figured out SHO. This part is done. Now it will start searching for K. Is K there? K there?
ASHO, it will start from A, right? ASHO. A is fixed.
Yeah, A, we got it. Now it will look for SHO for the, like, it is looking for the remaining string now. Okay, so now it figured out SHO. Are you getting it?
Yes.
Okay.
so
Now,
one second. So when we are doing that contains of A in the entire array, so what we will get is 1, 2, 3, 3 elements, which is Ashok, and then AS as the second element and A as a.
I'm not getting you.
Oh, okay, okay. So the starting from the first step, that is we are starting looking for A in the L array. So
It will
contains
specific look for A, not
A.
Ashok, AS or A. Only A. Okay.
Just A.
Contains function work in the way it is comparing the exact value. Okay.
Okay, now I'm
Yeah.
clear.
When it is looking for SHO, it is exactly looking for SHO. Next, when it goes for K, okay, when it is going for K, it is not able to find K in this entire process, right? Yes. Then it will look for Ki. Ki is possible? No. Kit is it there? No. That means this specific combination will return false. Now, it doesn't mean your search is over. What it will do next, KIT was not able to find, then we will back traverse and see if there is a possibility of finding out OKIT in this entire list. Is it possible? No. Then what it will do, it will back traverse and check if HOKIT is possible. Sorry, my bad. I've done it. Yeah. So this specific combination was not able to find it. So this will be discarded. My bad. We will not go from here. Next time what it will be doing, A was found. Now it will be looking for AS. Is AS there? Then next thing it will be doing, it will be looking for H. Is H there?
Ma'am,
HO?
ma'am,
Yeah.
one thing I did not follow is that we are going in the right direction, that starting with A, then finding the next element all throughout. We did not find any. So we are starting over again from,
Correct. We
okay.
are starting over again from A and S, increasing the length slightly. Then it will
Okay.
look for HOK. HOK is also there. So it found out this partition. Next, it will be looking for I. I is there. So I will be figured out. And next, it will be searching for T. T also will be figured out. As soon as you are able to get your entire string, it will be returning true. So this is what gonna happen. Uh, Anyone who is not clear with the idea of this question, like what's happening? Yes, no, anyone? I'm just talking about understanding of this question, not the approach that I explained right now or anything, just the question. Clear, okay. Others, what about you? Clear, okay. So if this is clear now, I'll be explaining the solution to it tomorrow, because if I start explaining it now, it will be taking a little more time. So we'll discuss that tomorrow, okay? Okay, then I'll just end the call now. Thank you everyone for attending the session today, and have a nice day. Bye. Okay, Kishan, we'll try to send the questions on recursion today. We'll definitely try to.